think we have this set up. We're using a new tool for this broadcast. So there seems to be yeah, we're actually able to live broadcast out to YouTube and Twitch, which is pretty awesome. So can people hear me? Is this all going okay? There's a little less feedback here, so it's a little tough to tell. Can I zoom in on the screen a little bit? Yeah, that's a good idea. How is that, Dan? Yep. All right, we should probably do the same thing over here. So as the caption says, we're going to be fixing a KV bug today. The kind of an involved bug that involves a few moving parts that we were able to prove yesterday actually allows for, in a very specific circumstance, a serializability violation where a read that was served before a range merge is applied can actually be invalidated by a future write at a lower timestamp, which is kind of breaking an invariant that's pretty important to Cockroach's KV layer, and so we want to make sure we can fix that. Now the way that this bug takes place is that we can have, well, typically during a range merge, every member of the left-hand side of the range is going to apply the merge through a raft entry. So a raft entry will be applied onto the left-hand side of the merge's raft log, and each member of that range will apply that entry, and by doing so, it will kind of take control over the previous right-hand side of the range. And so we can go from keys maybe 1 to 5 on the left-hand side and 6 to 10 on the right-hand side. And once we apply this merge, the left-hand side range will now be responsible for keys 1 through 10 all the way through. And so typically, under normal operation, everyone's applying this through standard raft log application. And so so it gets an entry in its raft log that says initiate this range merge. Now, what happens here is that we can have a case where members of the left-hand side of the range don't hear about the merge through their log. They actually hear about it through a raft snapshot. And a raft snapshot is kind of a bulk transfer of all of the data within a range that takes place when the incremental changes that are in the log are no longer able to be used to catch up that left-hand side, or to catch up that replica. And that typically happens when a replica falls far enough behind in the raft log that other members of the range decide to truncate that range's log. What can happen here, and it's pretty difficult to get this to happen, but we were able to reproduce a test, or reproduce the issue in a test, is that if the leaseholder of the left-hand side of a range merge is somehow in a state where it actually learns about the range merge through a raft snapshot, then it will incorrectly handle a few things about that merge. Specifically, it will not update an in-memory data structure that is used to prevent writes from rewriting history, from invalidating a previous read. And so this is pretty rare. In fact, I doubt we've ever seen this because it's extremely difficult to get a leaseholder to apply a snapshot. Cockroach does not have a guarantee that the leaseholder for a range, which is the replica that's in charge of serving reads and initiating writes, it doesn't have a guarantee that this is the same replica as a raft leader, who is kind of the head of the raft group. But it, for all intents and purposes, stays that way almost all the time. We do whatever we can to move the raft leader over to be co-located with the leaseholder. And so we need to enter one of these states where the raft leader and the leaseholder are on different machines. And if we do that in just the right way, and then we initiate a range merge, we can get this behavior where the leaseholder itself will apply the raft snapshot. And in doing so, it will violate a read that could have been served on the right-hand side, the previous range that was on the right-hand side of that of the merge. And so where we got to so far, and the goal over the next hour is going to be to fix this bug. So where we got to so far was that we'd extended a previous test called tests or range merge timestamp cache. That was verifying that the timestamp cache on the left-hand side of a merge was properly updated so that it would not serve any future writes that could invalidate a previous read. And so this test was only handling the case where the merge was applied through standard log application. It wasn't handling the case where it was applied through a snapshot. And so we extended the test to, because we have another variant. So there was already this variant that the left-hand side and the right-hand side of the merge had co-located leaseholders, so on the same machine, and also disjoint leaseholders, so on different machines. And we handled both of those cases correctly. What the test wasn't testing for was if the leaseholder of the left-hand side had applied the merge through a snapshot. And so the work that's done so far is extending the test so that we can also test that case. And when we do so, and it requires actually a fairly difficult dance to get this to work right. We have to isolate the left-hand side's leaseholder from its leader. So we have to effectively cause the left-hand side's raft group to demote the leader and re-elect a different leader. And then we need to write some log entries on that range and then truncate the log so that the leaseholder is actually, it actually needs a snapshot. The reason why this is very difficult to do in practice is because the leaseholder is the one who decides to make these decisions. And so we kind of need to get in this state where the leaseholder is making a bunch of decisions that it doesn't actually hear the results from, but the raft group will actually cause those changes to happen and get to a state where when the range merge is initiated, the leaseholder will hear about it through a snapshot. And so if we do all this just right, and so this is where we got to yesterday. If we do all of this just right, then this test, which we're running the variant with disjoint leaseholders between the left-hand side and the right-hand side range, and learning about it through a snapshot, this should fail. And what it will say is that we served a write on the post-merge range that should have been prevented and is actually violating a read that we had previously served on the right-hand side range, the pre-merge right-hand side range. Yeah, so that's what we see here. So we expected the write to be really pushed above a previous read, and it wasn't. And so, yeah, the goal here is to fix this. And this is tangentially related to a change we had been meaning to make. I'm actually going to turn off this caption. And so we had stumbled upon this because we were planning to make another change where we would ship larger, kind of high resolution versions of the timestamp cache across lease transfers and range merges. And the idea here is that if we ship a higher resolution version of the timestamp cache during these operations, then we can avoid some transaction retries or transaction aborts because we can be less pessimistic about what could have possibly happened on the previous leaseholders. And in doing so, we realized that we were handling the case where a lease transfer was applied through a snapshot, but we were not handling the case where a merge was applied through a snapshot. And so, yeah, up to this point, kind of lined up what the what the steps we were going to need to make to to ship this summary of the timestamp cache would look like. And in doing that, that's kind of when we stumbled upon what would happen in this case, and we realized it was broken. And so what we want to do, so let's go to store merge. Let's see how a merge is typically applied. So this method is under kind of when applying logs to our log entries to our state machine. We have a number of kind of post-application triggers that they fire, and one of them is handling the range merge itself. So we a given log entry can have what we call a non-trivial replicated evaluation result, and if it does, then we'll kick off kind of post-application hooks that will manage things. And in this particular case, we're managing the merge. And the important part about this, we do a few things on the when applying a range merge. But the important thing is that we're going to say if we are the left leaseholder and we weren't the right leaseholder, then we're going to move up our timestamp cache to prevent any violations of reads that we'd previously served. And we're going to do that to the time that we know that the right-hand side had stopped serving reads. And this is what is missing from the other way that we can be applying these range merges from the snapshot code. And so yeah, we do correctly handle the case where the lease was moved over over through a snapshot. And so that's probably where we're going to need to handle this second case as well. But there's a question of whether we want to generalize things a little bit. Instead of doing this directly based off of a lease versus snapshot, or a lease versus a range merge, whether we want to talk a little more generally about just shipping portions of the timestamp cache over and actually keeping some summary of the timestamp cache, attaching that to a range's state. And so this is about as far as I've actually gotten to thinking through how we want to do this. So there might be less coding at the beginning of this than maybe in the later portions. Also encourage anyone who has good ideas to post them about how we want to handle this. For people, I don't know how familiar people are with this area of the code. But the first thing that we need to do, and it seems pretty clear that we need to do it, is we need to create some representation of what a summary of a timestamp cache would be. And so we can go to, so let's kind of just mock this out. We'll actually need to create this in a protobuf, but for now we can just mock this out. Let's just say TS cache. So it's going to have a so there are two portions of the range that we need to bump when we apply either a lease transfer or a range merge. There are two portions of the timestamp cache that we need to bump. One is called the local portion, and one is called the global portion. And so we're probably going to want in our summary just kind of being a summary of all of the reads that a previous leaseholder has served. We're going to want to track kind of a chunk of this for the local portion and the global portion of the key space. And so we can just say we're going to have two chunks. And the most basic way to summarize this would just be say, so we could just say the upper bound. So let's see. All right, Dan just told me the logo is blocking things. Is that better? I like the logo, so I'm sad to take it off. But we'll go with that. So the task here is to summarize what's inside of a portion of the timestamp cache, and we can do so while losing some resolution. But if we're going to do that, then we need to make sure we're pessimistic in terms of what could have been in there. And so the easiest way to do that is just say what's the maximum timestamp within some key space, and if we do that, then if we apply such a summary, we're not going to violate anything in the previous the previous cache that we took this from. It also gives us the nice property that we can write a commutative merge function for the summary that would look something like, let's just write it for the chunk. So we could just merge, we just forward the upper bound. So we're still kind of tracking the upper bound of now that's merged summary. And in the future, what we would want to do, and kind of one of the big desires here is to be able to say something more like upper bound minus high res portion. Bad names, but and then we could have we could have a set of key timestamp pairs, I guess, that would actually be full resolution, and this would be maybe the last second of time actually at full resolution, which means that we could apply a covering at this upper bound minus the high resolution portion, and then just apply specific parts of the timestamp cache. And this would be an optimization. We don't need to do this yet, but we'll want to make sure we keep the option available. And so to do that, we'll want to make sure that the protobuf that we're eventually going to write this up in is compatible with such an extension down the line. For now, though, let's talk about how you would collect. So collect and then apply such a summary. So the timestamp cache itself has there's a few nice methods. The one that's going to be most useful here is just GetMax, which will return to us the maximum timestamp over a span of keys, which is exactly what we want. And so we can actually just look at the maximum timestamp over our local portion of the key space and over our global portion of the key space, and that will be our summary. We'll clean this up later, but I just need to figure out, we'll need to figure out what the actual spans within the range R, the key bounds, given a descriptor. We don't want an MVCC key, we just want a normal key. Yeah. So again, we'll clean this up, but this will be kind of the high-level idea. So we don't actually care what the if this was bound to a transaction or not. We'll just assume it wasn't. And so that's it for summarizing what's inside of the timestamp cache on a given range. Fairly straightforward, as long as we as long as we're okay with such a loss of precision. And now the second half of this is basically doing the reverse. And so we are going to we are just going to similarly, yeah, to some other code we had here. Actually, yeah, okay, so we can use this set low watermark method, which I believe is the same thing as add. It just doesn't take a timestamp or a transaction ID. At least given the current implementation of this cache. So we can use this. I think it used to do something differently back when this cache was based. It was implemented using an interval tree, but it's now implemented using a lock-free skip list, and so there's no difference between these two methods really. Actually, we can confirm that. Yeah. So this actually, right? It just calls right into add, but let's use it anyway. So let's grab the descriptor again. Some locking here that's probably wrong, but we can fix that later. All right, so we now have some way to represent a summary of the timestamp cache. This is a pretty low resolution approach. And so we're not going to get any of the benefits really of doing so versus the current approach. But we will be able to extend this later on to do what we talked about before, to ship maybe a slightly lower upper bound and then specific points that need to individually be raised within the timestamp cache. So the next step is going to be to represent this in a proto structure. And we're going to need to do so. I guess it should probably live here. Let's go to lease lives. Yeah. We should not live on a lease itself. We have a replica state. Okay. Segment. I suspect that we'll want a constructor here for, at least for the migration path, to just promote a timestamp, which is currently how we pass things around, as kind of representing the upper bound of both portions of the timestamp cache, and promote that into a full summary so that we can work on summaries from now on. Make sure this make sure this looks right. Yeah, that's right. Call this upper bound. So exciting news about Visual Studio Code is that Go Please is now on by default, which means you get these nice long saving dialogues every once in a while, or often. Has something to do with the Go format or something along those lines. Kind of unclear, but most of the time it's fine, and sometimes it gets very slow. The trick is just that formatting is good enough for now. So we'll just say that the local and the global portion both going to have the same segment. It's just the timestamp as the upper bound. Let's then and some of our other methods that we copied over from the non-proto version. I think we're calling this a segment now. You might want a more general version of this. Did I spell segment wrong? Segment. No, I didn't. So this merge function is going to combine two of our summaries and create a single summary that, yeah, how do we describe this? That word. well, we need to add some nice words here. Discussing. All right. So now I think the time has come to rip out these old summaries and replace them with the protobuf version. So one kind of incremental step we can take now, which would be interesting to see, is whether we can replace this existing function, this set timestamp cache low watermark function, which is called on range merges and lease transfers during the normal log application approach. We can check whether we can get rid of it and replace it with our new summary approach by using that helper that will synthesize one of these summaries just from a timestamp. Just as kind of a check that we are doing everything right. I guess in this function here, our apply timestamp cache summary function. Do you think we need to? Oh no, we don't have the description. Not locked there. Okay. This is nice, actually. It doesn't place any hard constraints on locking, just by just being a free function. Whoever calls it can just pass in the timestamp cache in the descriptor, and everything falls out of that. So let's do that here as well. Okay. Let me just add here. Make TS cache summary. All right, that works. basically the same thing in store merge. Yeah, here's where that the fact that we weren't requiring this to be a method comes in handy. So we pass in whatever descriptor we want. And in the case of the merge, we're actually just updating the right-hand side. Just what used to exist on the right-hand side of this merge. And so as a check, let's test all variants of this previous test that was checking to make sure that well, is this gonna work? No. Let's check all variants over here. And this should, I guess 3 out of the 4 should pass if we did everything right. And then if we don't apply the summary, 2 out of the 4 should pass. Just the disjoint leaseholder test should both fail. But right now what we're doing, we're using this new summary just kind of on the ends. Just when we're actually applying the timestamp, just make sure that things are working as expected. Well, I guess that's taking a while to compile. So while that's compiling, we can talk about how we're going to ship around these summaries, because that's really the goal, is we're actually going to start shipping them around. And so there are a number of places we're going to have to ship them around. Let's think through them. So actually, I think we have that spelled out over here. So we want to start storing them on the range state itself, which I think we found that was in user. And so this is going to be a compressed version of this summary. A year from now, just in case. So primarily for cases where we are learning about a snapshot or range merge through a lease transfer or range merge through a snapshot. In which case we need to remember the summary even past the point of the log application. And so we need a way to store this on the replica itself. And this range state proto, which is never actually persisted, but it provides us a nice way to hold this in memory, and then also reference the denormalized state on disk. Let's just do this is still compiling. All right. Maybe it wasn't compiling. It's possible that we actually run it. It's possible that we just had stall in the test itself. Okay, well, that compiles. We can start talking about lease transfers, which was the original motivation for this change. Was that we were going to ship these summaries around, and during a lease transfer, instead of using the lease's start time as kind of doubling up the meaning of the lease's start time to be an upper bound on the operations that had taken place on the previous leaseholder. And the reason we needed to make this change was because we are now allowing future time operations to take place on the leaseholder. And so the start time of the next lease no longer has the same meaning it used to. Okay. Well, why don't we just say, we're just going to look at the old cases. This through snapshot test was the one we just added, and it's pretty delicate. Probably got something wrong there. But the through snapshot equals false cases should both pass right now. And then they should, one should fail if we remove these two lines. Yeah, so they both pass. Now let's take this out of the equation, and we expect the disjoint leaseholders equals true case to fail. No, I don't think people can see. We're gonna have to talk to Jordan after this about getting music going. This is a quiet hour now that I can't actually hear people speaking and can't talk to people directly. Oh. This Jordan is here on Twitch. We got this comment. Surprised this is taking so long. All right, we see, yeah, so we see the test we thought would fail. We see that fail. and with the error we thought it would. So what happened is we served a write that violated a previous read, and this is actually the exact same case that is failing for real when we're applying a snapshot through, or applying range merge through a snapshot. So that's good. We didn't do too much here, but something's working. So let's plumb this further. What we want to do is during a range merge, the way that we ensure that a read from the right-hand side is never invalidated by the kind of post-merge range is that we, while locking down the right-hand side range, so we call it freezing. Well, we freeze the right-hand side range during a subsumption request. We gather its clock time, and this is again an assumption that we're never serving operations above the local clock, which is not true anymore. And so we're also going to need to basically say, go to the right-hand side while freezing it. We're going to say, give me a summary of your timestamp cache, and return that to the transaction that's coordinating this range merge. And then that will need to then ship the summary over to the left-hand side. And so let's we have the stats of the right-hand side range, we have the least split index, and now we also have the freeze start. And now we need one more field, and that's going to be our TS cache summary. Let's keep this nullable for now, so we can detect when old nodes are, we're talking to old nodes who won't know to even populate this field. Next, we're going to need to give the subsume request access to our summary. Let's here. All right. There's this part of stored case cache. So we should be able to do something like apply.ts cache summary equals and this should compile. And so I'm also going to switch this back. That is back, okay. So if that compiles, then we're well on our way towards shipping these summaries when in cases where we need them. And then in doing so, we're also going to be able to fix this original bug that we had. We'll maintain on a range some compressed version of this summary indefinitely. And so we'll compress it down well enough so that we feel comfortable actually storing it directly in memory. And whenever we send a snapshot, we'll just carry along this this compressed version of the summary. And that should be enough to, yeah, that should be enough to allow a leaseholder who's learning about a merge through a snapshot to bump its cache, its timestamp cache, probably pretty inefficiently. It'll probably bump it up kind of board across this entire range. But that's fine because we really don't ever expect this. Okay, so yeah, we. Let's see. Yeah, imagine. Let's just give this a custom name. And yeah, this is. We're just going to leave this unimplemented because we can implement it later. And so if this passes, I think we can probably call it a successful effort so far. We haven't done much, but we are starting the process of actually plumbing these chunks of timestamp cache through various layers, and we're on our way. So while that's going, we can walk through kind of a high level overview of what we're going to do once this subsume response is handing back the range merge transaction, the summary. So we can look at that transaction in replica command right here. So what the range merge transaction does, and this is all leveraging the fact that KV is built off of serializable transactions, and so it's able to be, it's not nearly as complex. Well, if Nikhil is watching this, I shouldn't say that. It's extremely complex, but it at least has the benefit of being able to rely on a serializable transaction to operate. And so what it does is makes a number of modifications to different range descriptors stored throughout the KV key space. So on the left-hand side of the range, it modifies the range descriptor to extend its key space, and on the right-hand side range, it just deletes the range descriptor. It then co-locates replicas, or that might be done a little before. But anyway, once it gets to a place that it's happy about, once it gets the replicas of each side of the merge into a good place in terms of all replicas having a co-located replica from the right-hand side range, it then locks down the right-hand side range. It sends this subsume request to say freeze all operation, pause all requests, and handing back some state about the merge and about the right-hand side range. And so once it does that, then the transaction will initiate a commit of the merge, sending that to the left-hand side. And in doing so, it's going to pass down some information. So we can see how we grabbed while locking down the right-hand side, we grabbed its freeze time, the time at which no operations had taken place above, which is no longer true. But we grab that time and then we ship it to the left-hand side so that when applying the entry, we can use it. And so the next step, we're not going to do that here. Oh, I see. Yeah, let's. we clean this up later, but the next step of all of this would be to actually plumb down the summary onto the left-hand side range. And to do that, we would add into this merge trigger proto the summary. And then while applying the entry on the left-hand side range, we can now use that summary instead of just this freeze start time to bump the timestamp cache. All right. Not implement. Here's this. Let's see. All right, last try. I don't know how interesting it is to see compilation fails over and over again. But I think this one's going to work. Yeah, sure. And so to take a step back while this is compiling, it's interesting to ask why we need to be shipping around this information, why the timestamp cache needs to exist in the first place. And all of this is coming out of the fact that Cockroach doesn't perform, it doesn't achieve consensus on reads. Instead, it has this leasing mechanism so that a leaseholder can serve reads locally. And so that's a big benefit, both in terms of throughput and latency to the entire system, that a leaseholder can just serve a read locally. But it means that also a leaseholder kind of has a pretty special role in the whole kind of in coordinating operations, and so it needs to make sure that if it does something, it tells everyone else about it if it's going to hand over control. And so by shipping these summaries around, we can allow the leaseholder, when it's giving up control over portions of the key space. All right, we passed. So yeah, we can allow old leaseholders to tell new leaseholders kind of what they did and the effect they had on the range, so that no one is invalidating something that a previous leaseholder had performed. And so we passed. We have this compiling now. It really doesn't do anything, but we're starting. The structure is starting to take place, and I think it's kind of an exciting side effect of this, and I think various people will be interested in this, is that this timestamp cache summary structure, once we get this plumbing all in place, we can do some extensions here to ship more high resolution versions of this, and actually avoid some transaction retries. So we can make lease transfers less disruptive by shipping the last second of reads kind of fully at full resolution. We can make range merges less disruptive. And so it does tie into avoiding transaction retries, which is something that people, people don't like them. So the more we can get rid of them, the better. So I'm gonna end it there. Thanks everyone for coming, and maybe in 2 weeks we can show the final result here, and we can hopefully have that test passing, that original test. So thanks everyone.